Still getting chicken grease off my hands. I thought I'd have a bigger intro than that. So yeah, well, I'm really excited to be here. I'm really excited to have a chance to talk about what's become one of my favorite things, and that's Docker. So kind of the idea today, because Docker's one of those, like a lot of technologies, to where you can cover the basics really fast, or you could spend like 6 weeks digging into the depths of it. So the goal is to give just kind of an overview and hopefully show some examples, give you a little bit of a taste of it, and then we'll have time for questions at the end, where hopefully if there's something that kind of piqued your interest, maybe we can dig into that a little bit more. So one of the reasons that I'm so excited about Docker is because Docker has become one of the core parts of my toolkit. I would really, at this point, put Docker almost on par with source control. Like if I'm starting up a new project, it goes in source control and I put it inside of Docker. It's become a huge part of my workflow. And so hopefully I can at least make you curious enough about it to give it a shot. So is anybody used Docker, or they've played with Docker, or you've heard of Docker? Okay, good. So, this is definitely targeted for somebody that's maybe just played with it. So for those of you that have more experience with Docker, I'd love it if you can think of questions, or maybe we can dig into something a little more in depth when we get to the end. So a little bit about me. My name is Jeremy Waller. I'm a developer here in Oklahoma City. I've been a developer for about 15 years, and I've been doing .NET for about the last 7 or so of that. And connect with me on Twitter. I'd love to connect with you guys and just be able to talk about this kind of stuff or anything else that's going on. So definitely, if you have Twitter, check me out. I'd love to follow you back and connect with you more that way. I work for a company called Phase 2, and Phase 2 is a software consultancy, which that means is I get to work on some really interesting and challenging problems, and that's actually how I got hooked onto Docker, is we were working on a product that had a pretty complicated environment. There were a lot of dependencies. There was kind of an unusual production environment that this was going to go into, and it really wasn't feasible to set up a production-like lab. We had to find some way to be able to run this locally, or at least run this with more limited resources, but still have confidence that this thing was going to work when this actually went into the production environment. And so Docker was actually how we came about solving that. We started looking into it, and it ended up being a really great fit. So Docker is really awesome for that. The reason I have a picture of hacky sacks is, like I like to do, I bring hacky sacks with me, our Phase 2 hacky sacks. So if you have questions, think of them, save them, because anybody that asks a question gets a hacky sack. So I like audience participation. I don't like just talking at you for 45 minutes. So be thinking of any questions as we go. So let's talk about this. What is Docker? So Docker is a software utility that took something that had actually been around for a while, the technology of containers, and put a nice, neat little bow around it. It took something that was kind of messy, kind of complicated to work with, and gave us a really great, simple utility to be able to work with these containers. And so you hear the term of Docker and containers, and they're kind of sometimes used interchangeably. But really what we're talking about is Docker is the utility that makes it really easy to work with containers. And so at a high level, Docker is a utility that makes it easy to create, ship, and run containers. Now, that's really all we need to know about Docker itself. What we really need to talk about are containers. What are containers? How do containers work? Why are containers so great? And so let's talk about that a little bit. A container, and this was a hang up for me when I first started getting into Docker, is I couldn't wrap my head around this abstract concept of what a container was. And the easiest way for me to think about it is a container is almost like a virtual machine. We're doing some hand waving a little bit there, but that's the easiest way to think about it conceptually, is it's like a virtual machine. And so the same things you think about with a virtual machine, it has process isolation, it has its own file system, you have control over networking. All of that is true of Docker containers. And so conceptually, if you can't get your head around containers, think virtual machine. It's similar to that. The big difference, though, is that each container shares the host's operating system. And so the problem with virtual machines, especially if you've got something that requires a bunch of VMs, is you got a lot of overhead. It's probably, if you're trying to run a bunch of VMs locally, you're going to hit a wall pretty quickly. And so containers give you a lot of that flexibility of having virtual machines, but without all of the overhead of running a bunch of different operating systems. And now, just like a virtual machine where I could spin up a virtual machine, I could snapshot it, I could then take that snapshot and give it to you, or I could put it on a box somewhere else, and I could restore that and it would run. Containers are the same way. If I build an image for a container, I can deploy that image anywhere. I can create a container from that image, I can give it to you, I can put it up on the internet, I can put it in AWS, and it will all run the same way. So containers make it really easy to have consistent deployment across environments. For any of you that are more visual, here's a picture that maybe gives a little better image of what a container actually is. So on the left, you've got a virtual machine, you have a couple of applications, they have their own dependencies, and then that virtual machine has an operating system that it's running. That then runs on a host operating system that's ultimately running on some kind of hardware underneath, so normal setup. On the right are containers, which are very similar, except there's that guest OS missing from there. You don't have an individual operating system for each of these containers. They share the host's operating system. And so that's one of the things that makes containers really great, is because they're really lightweight. You're not running an individual copy of Windows for every virtual machine you're spinning up. I can have one copy of Windows, and then I can have a bunch of containers running on top of that. So that's the technical part. That's really as technical as we need to get when we're talking about Docker. What we need to talk about is, why do we love Docker? Why is Docker so good? Why can I get excited about something? Why can I get excited about containers on top of a whale? The Docker has some really great benefits that I want to talk about. And so Docker does a lot of things, and I want to hit on 4 specifically. And we're going to do some demos here in a minute to kind of walk through some of this stuff in more concrete terms. So Docker lets us build an app once and run it anywhere. So once I have built my image for my Docker container, I can put that up on a repository somewhere, and anybody in the world can pull that image down, and they'd be able to run the exact same container that I'm running on my local machine, which means I can do it amongst my development team, I can put it out on a test server, I can put it out on a production server, I can deploy it in any cloud-hosted provider. It doesn't matter. It will run the same everywhere. Once I've built that image will run exactly the same way every time. It also can eliminate shared development environments. So I don't know what kind of stuff you guys might be working on, but I know I've worked on projects that it's not really feasible to run locally. It's too complicated, there's too many dependencies, it's too resource intensive. Whatever the reason is, it's just not feasible to run it locally. And so there's some dev environment, there's some box out there that we all use, we put our code on it, and that's the thing that runs whatever it is we're working on. Or maybe it's the dev environment that runs some dependencies, and then I'm running locally against that. That's great if it's just you, but if you've got a team of developers, you have to put your code out there, and then somebody else needs to deploy your code, and you're working on different things, and you're stepping on each other's toes, and then you add QA into the mix, and they've got their test server that you're putting code out on. Well, that environment's locked down until they're done testing that story, and then you've got staging you've got to worry about, and then you've got your users that are testing it, and it's this mess of these shared boxes of people needing to access them, and you can only have one version of it on there at the same time. With Docker, that's not the case, because it's so easy to run this in a local environment. Everybody can run this on their local machine, or I can even have one server, and I've got multiple instances of this. I've got multiple containers running on that one shared server, so I'm not stepping on anybody's toes when I'm trying to work on my code. Along those lines, it also makes project setup a lot easier. I've had projects I've worked on that, like, if you printed the documentation out, you'd have 15 pages of setup steps to get the right dependencies, and you got to set environment variables, and you got to have the right version of Visual Studio, and you got to have this installed. And then I'm also working on this other project, and they have conflicting dependencies, so I've got to do this dance to be able to hop back and forth between projects. And it's literally sometimes days of work to get your environment set up where it will work right. And then you have a bug. Well, is it my environment that's broken, or is it actually a problem with the code? And I've had that, and I've had problems of I see some open source project that I want to go work on. I think it's cool. I want to play with it. Oh, well, I've got to do this, and I've got to do this, and I've got to install this, and I've got to have this. And it's such a chore to actually get my environment set up that I don't mess with it. So Docker makes it really easy to do that. Once you have this configured, you can literally have somebody sit down, and in 30 minutes they could have their full development environment set up, because it's running one command, and Docker does everything for you. And the last one that we're going to talk about today is that it makes it really easy to do load testing. So I can actually do load testing on my local machine. So if I have something that I want to run multiple clients against, I don't actually have to have multiple clients to do that. I can use containers to do load testing on my local machine. So what do we do when we want to try out a new technology or new language? We run, it's on the slide. Thank you. So let's actually look at a demo. Let's do a Docker hello world. So if you go out and you install Docker, you go through the installation steps, which is actually really easy. It's like an installer that you install. There's nothing complicated about setting up Docker. One of the things it'll tell you to do right after that is to do the Docker hello world just to confirm that everything's working in your environment. So you can see here that we've got Docker running. I can see I've got the community edition of Docker, which is free. You can go download it, install it, no big deal. And then with that, we can tell we want Docker to run something. So it's literally Docker run, and then what are we going to run? We're going to run hello world. So what Docker's doing right now, we'll give it just a second. It just ran hello world. So we can see here, we've got hello from Docker. This message shows your installation appears to be working correctly. So our Docker is working. This is our Docker hello world. And if you caught it, it went by quickly. We'll scroll up here. Docker did some magic things up here. We told it to run hello world, and it told us it couldn't find the image hello world latest locally, and so it pulled it from somewhere. It went and downloaded something, and then it pulled that, and it ran that on our machine. So hello world was nothing I downloaded. It was nothing I had to build locally. It knew by me saying hello world that it needed to go get something and run that on my machine. So let's go look at that. What is hello world? If we go out here, we'll find something called Docker Hub. Docker Hub is a repository for Docker images, the same way you've got NuGet or you've got NPM or any other repository. Docker has Docker Hub that has, I don't know how many images, thousands of images, tens of thousands of images out there that you can pull and use. So when we ran hello world, it saw I didn't have anything called hello world on my local machine, so it went out to this repository and it downloaded the hello world image for me. Now we can actually look and see, here's the latest that we ran. And even though we're in Windows, we're actually running Linux containers right now. And so it ran this. We're out on GitHub now. If it'll let me zoom in, there we go. We'll talk about this in just a second, what this actually means. But this is our Docker file. So this is the thing that just defined what our Docker daemon did. It went and it executed this Docker file, and that gave us the output that we just saw in our console. And we can actually look and see that it ran something called hello. So if we look in the repository, we can actually see that there is a file out here that was executed, and there's our Docker greeting that we just saw. So there's a repository out there. Somebody built an image off of it. I was able to download that image from the internet and run it on my machine, and it works the same on my machine. It would work the same on any of your machines. It would work the same on any machine that's running Docker. It will execute the exact same way every single time. Now, this is obviously a very simplistic example, but that's what Docker does. Docker lets you take this script, this Docker file, and it will execute those same steps on Windows. It'll execute the same steps on Linux. It will execute the same steps that if you're running Docker, it will run the exact same way every place, every time. So Docker lets us do some really cool things when you're talking about deploying code. So let's talk about the Docker file, because the Docker file is kind of the heart of how Docker works. The Docker file is the thing that defines what actually goes on in your environment. It's our way of telling Docker, here's what we want to do, here's the steps that we want to follow, and it's the thing that gets executed whenever we want to build an image. So it specifies a starting base image. It says, here's my starting point, then I want to do steps 1, 2, 3, 4, and then I have my image once that's done. And so that can be it can be copying files in, it could be executing scripts, it could be running an installer, it could be installing Windows features. It doesn't matter. Anything that you can potentially script out, anything I can go into PowerShell or go into a command line and I can type out some command, I can tell my Docker file to do that. If you've ever worked with something like Vagrant or something else that lets you script out an environment, it's the same idea. It's just a much cleaner, simpler way of doing that. I'm issuing commands to my container or my virtual machine with how I want it set up. And the Docker file is the way you do it. Nothing happens in your container unless the Docker file says so. So it's our roadmap for how the container gets built. So this is the Docker file we just looked at in GitHub a minute ago, and it's 3 steps. That's all it is. It's this one. It's from scratch, which is Docker's cute little way of, they call their base image scratch, so you're making it from scratch. And that's our starting image. That's our base image. It then says copy whatever hello is from our host to the root of our container. And then we execute this command. We run the hello script. So that's all it was. In this case, it was just a C binary that gets copied in and gets executed inside the container. It's nothing fancy that's doing. But it's just those 3 steps is what actually defined that image. Now that in and of itself is not super useful. You can't really do much other than execute a script there. So let's look at a more real world example. So I don't know, has anybody played with .NET Core yet? A little bit? So one of the cool things that Microsoft's doing with .NET Core, when you start a new project in Visual Studio 2017, there's a little checkbox that you can include Docker support. And if you check that, then it will generate this Docker file for you. So this is a Docker file that gets generated by Visual Studio if you start a new .NET Core project and you include Docker support. This is where the audience participation comes in. So I'm going to ask questions, and that means you answer. So let's go through this. So from what are we saying? Somebody, what's the first line doing? What's that? Yeah. So Microsoft has given us an image. If we actually go back out on Docker Hub, we can look at Microsoft, and Microsoft has a long list of images available to us. Everything from Nano Server, which is a few hundred megs, that has just the core Windows dependencies, all the way to like a full-blown Server 2016 that's like a 6 gig file to install. So Microsoft gives you tons of images that you can use as your base image. So then we're gonna start from that. So we have a Windows environment that we're starting from, and then we're gonna set a work directory. And then what are we doing on our next command? What are we copying?
Copying local project files into our Docker.
Yep. So we're taking. So let me back up one point. So this is all relative to the folder that our Docker file is in. So this Docker file is going to live right alongside your project. So we're saying copy all the CS project files that are in our folder into the container. And then what are we running next? Yeah, NuGet restore for .NET. So you run .NET restore. So this is actually executing inside of the container. So we have a container running, and inside that container, that command gets executed. And all this container knows about are these CS project files that were just copied in. It has its own file system. So it just has these CS project files. You run .NET restore, and it does a NuGet restore inside of that. Then we go back and we copy everything else from our roots, the rest of our project, into the container. And then what are we doing after that? Yeah, it's a publish. It's not a trick question. We're just running .NET publish, and we're passing some flags. It's doing it with a release configuration, and we're specifying an output directory of out. And then finally, our entry point, which we'll talk about that, but all we're doing there is we're telling .NET to then run that DLL. So that's it. This is the file it gives you, and what that does is it allows you to build your project inside of Docker. Yeah.
So in your hello world, when we had command statement,
Uh-huh.
what's the difference between command and run?
Yeah, so that's a good question. So the question is, what's the difference between command and run? So if you actually go look at the documentation for Docker, there's a couple of little quirks. So when I'm actually building an image, I use the run command to execute some command. And that's going to execute whatever the default shell is. So with Windows, it's just going to be doing it in command prompt. I can set the default to being PowerShell, and if I said run whatever, it's going to execute in PowerShell. The difference with the last statement in your file, entry point versus command, is how the base image is built. So with Microsoft, they've decided that entry point is the command that gets run, and what that's actually doing, that last line gets executed whenever you run the container, whenever you run the image. So actually everything up until the run statement gets run when you build. That last one, that entry point, is actually what gets run when you bring the image up, when you actually make a container out of the image. So every time I start this container, that entry point's going to get run. And what that does, .NET, and you give it this out client DLL, every time I bring up my container, it's going to start that project, and it's going to serve up, or it's going to execute that DLL. In this case, client, that we'll look at in a second, is just a console app. So every time I start the container, it's going to start my console app. So that's the only difference. And you'll see, if you go out, look out at Docker Hub, It will tell you, and Microsoft's the only one I know off the top of my head that uses entry point. I might be wrong about that, but all the Microsoft images you'll see entry point, and it'll tell you this is, execute entry point, and here's the syntax for that, so it knows what to run when you bring up the container. That's a good question. Okay. So actually, let's look at that real quick before we go on to the next example. So we can actually go over here and look. Here's our Docker file that's actually living inside of our project. So we have a .NET project, we've got a client console application, and I have a Docker file that's living right alongside it. This is exactly the same as what you just saw on the slide. This is just it living inside of the project. And we can actually go to it. So we see here's our Docker file that's there. So I can tell it Docker build, and I'm just going to give it a period. Build the Docker file that's in this folder. I could give it some file path, but since I'm locally here, just build that. And it's going to go, and it's going to build that for me. Now you can see something else we need to talk about with Docker. Docker's really smart about using caching. So you can imagine if you have a big, complicated project, you've got a lot of dependencies, I've got containers that are doing database restores inside of them. You don't want to do that every single time you build. I make one small code change, and I've got to wait 20 minutes for the whole project to build again. So Docker's really smart about using caching. And since I've built this before, you can see in every single step, using cache, using cache, using cache, and so on. And so this effectively built instantly. Docker knew I hadn't had any changes since I last built this, and so there were, yeah. There is a no cache option. Yep, so we can say no cache. There we go. It didn't use any cache that time. So it's also really smart, though, even though we are using caching every time. Let that finish. And you can actually see as we go through, it is actually executing those steps inside the container, and we get our output back. So it's the same way as if I ran .NET restore, .NET publish on my local machine, and I get output from that. I see that when I'm building my Docker image here. So say I'm in here working, and I make some change to my application. All right, I've got a code change. So if we go back and we build that again, take our no cache off. What we'll see here is that it's going to go too fast. I'll have to let it finish so we can scroll up. There we go. So you can see step 2 using cache, step 3 using cache, step 4 using cache. And then we got to the point where we were copying the project inside the container. We're not using cache anymore. Docker saw that I have changes to this folder, so it's smart enough to know that it doesn't need to use cache. And since that didn't use cache, everything after it's now been invalidated, so it needs to build fresh every step behind that. So it's really smart. The downside to this is it's really disk intensive, so you've got to be good about going and cleaning up stuff you're not using, or just give it a really big drive to work on. But the time that you save, especially if you have big, complicated projects, is worth the disk space that it takes. So it's really smart with the way that it uses caching. And actually, we can come in here, and we can see there's a bunch of images that it has cached. And most of these are just the intermediary images that it's saved from where I've built different things, or the intermediary steps. So Docker keeps all that around until eventually, if you get rid of the container and all of the images it's dependent on, you can go through and clean everything up nice and neat to take care of things. But like I said, it's worth the disk space. Let it do its thing, and you'll save a bunch of time using the Docker cache. So that's all a Docker file is. They can be, like most scripts, they can be really long and complicated, but it's once you put that work in to build your Docker file, you can have a new team member walk in, or you can get onto a new project, and it's literally that simple. Docker build, and it's done. I don't have to worry about any environment setup. I don't have to do any jumping through hoops to be able to build this thing on my machine. I worked on a project that, this was not long ago, this was like 3 years ago, that had a specific build machine. It was a Windows XP machine that sometimes was on the domain, sometimes not. So you were lucky if you could connect to it, and it was the only machine that could build this. It was awful, but it's an extreme example of what happens when you've got all these environmental dependencies. And with Docker, you can get rid of all of that because it's all scripted out. It all runs inside of containers, so it doesn't matter what my local machine is. It matters what that container is. That container is controlled by the Docker file. So that's it for what a singular container is. So then what happens if I have multiple containers? What happens if I've got something that's more complicated? We're going to show an example here in just a second that's got an API that has 3 different dependencies for that API to run, and that API needs to be running so I can run my client application. And it's a little bit of a contrived example, but it's you can come up with something that you've worked on that's similar to that. And you don't want to have to do that for every one. I've got 7 things. I've got to go build this image, and this image, and this image, and this image, and then I've got to bring them up in the right order so all the dependencies are there. That's not fun. So Docker gives us a cool thing called the Docker Compose. And this is the only other file you really need to have to know about with Docker is your Docker file and your Docker Compose. And that's it. If you've got those, then you understand Docker. You at least understand Docker well enough to use it day to day. So Docker Compose makes it easy to run multi-container Docker applications. And it's just a YAML file, really easy to read, really easy to write, and it lets you build and run all of your containers with a single command. So let's, just so I show my slides, it's demo time. So let's go to a demo. Let's go look at that. So if we look at our Docker Compose, let's scroll down here to our client application. So our client application is the one that we just looked at. It's the one that we just built. Here's our Docker file for that we just looked at. Well, I've got that as part of a Docker Compose. And so I've defined a client here. And what I've told it is I want to build the Docker file that's in this subdirectory. So in my project here, you can see I've got my Docker Compose, and then there's this client subfolder. So all I'm doing is giving it a path, build the Docker file that lives here. And then I'm giving the image a name so I can easily find it later. That's not that important. That can be whatever you want to name your image. And then here's something that's really cool. I'm telling it has a dependency. It depends on something called an API. And if I scroll up, you'll see there's an API that's defined here, and it has dependencies that are defined. And this can be as complicated as you need it to be. And Docker is smart about bringing these up in the correct order so that your dependencies are there. I'm setting some environment variables. So if you have any projects that depend on environment variables, you don't have to mess with those on your machine. You can just tell Docker Compose, here are my environment variables that I need to set. And then you have full control over networking. So if you have some weird network you need to simulate, you've got stuff that's in different subnets, or you've got weird firewall rules, or whatever. You have full control over networking within Docker. In this case, we're just joining all these to the same network. And we also get DNS. Docker handles all the DNS for us. So inside of that network, I can just say, hey, client, or hey, API, or hey, Elasticsearch, or whatever that I've given these names. So networking is really easy inside of Docker. So that's it. I've defined my client here inside of this. And all these others are just different services that I've configured. We don't have to get into the specifics, but I do want to show Elasticsearch that's going to be part of this demo we're getting ready to do. You notice there's no build step in there. Elasticsearch gives us, or Elastic gives us, an image that we can use. So if I have something that uses Elasticsearch or some other program that I don't really want to install on my local machine just to be able to run this, there's a pre-built image that's out there. I don't even have to build the image. I can just go download that image, and I can run this. Elasticsearch, Kibana, and Logstash are the 3 we're using for this. I don't have to worry about any of that. It's going to download the image from the repository, and I'm done. And the same way works, you can self-host a repository, you can do a repository on AWS. So if you've got stuff internally that you're using, you can put all these images out there, and when you have a new project that needs them, I don't have to deal with that code locally. I can download that from my corporate repository or my shared repository somewhere, and I can specify that as a dependency for my application. So it makes it really easy, especially if you have complicated dependency structures for some of these projects. Docker Compose makes it really easy to manage that. Yeah? That's a good question. So the question was, is this a single container, or is this defining multiple containers? So each one of these services that I've specified will be brought up inside of their own container. So we've got, Elasticsearch, Kibana, Logstash, API, client. So we've got 5 containers we've defined here. So when we bring this up, there'll be 5 individual containers that are running. And you can imagine if you're trying to do this with virtual machines, running 5 individual virtual machines, you could probably do it. I mean, you could probably have a computer that can handle that. But if you do much more than that, I've got one that I work on that's 9 different containers that run. I mean, that's just the project. That's not anything, that's just all the dependencies and everything. You're not going to run that on a local machine. You're not going to spit up 9 VMs on your laptop, or even if you've got a really beefy desktop, you're not going to have a good time running 9 virtual machines. So Docker makes it really easy to manage this. So let's look at this. Let's look at what this actually looks like. So if we go back to where our Docker Compose file is, I'm going to see that we have our Docker Compose YAML file here. So let's look at that. Let's do a Docker Compose And let's bring up our API. And I'm going to give it a flag that we'll talk about here in a second. We're going to bring up our API. And we'll see here, since I've specified that that API has certain dependencies, it knows that Elasticsearch, Logstash, and Kibana need to be up. I didn't have to tell it to bring those up. I specified those dependencies, so it managed that for me. All I said is I want my API, and Docker Compose handles everything else with bringing my dependencies up. So now I can actually see, wow, that's hard with the text wrapping there. But there we go, it's a little better. So you can see we have a Docker demo API running, we have this Logstash running, Kibana, Elasticsearch. So all of these containers are running on my machine right now. And if we actually look, I'm running this in parallels, and I've given parallels 8 gigs of memory. So you can imagine if you had 4 virtual machines running, plus your host software. I'm just under 5 gigs right now to run my host and 4 containers. So it's very lightweight. So if we go out now, we can actually look. So this is running on localhost now. And all this API is you send a GET to an endpoint and it sends you the resource ID back. So that's all we're doing. We're not doing anything fancy with the API. But all I had to do was run Docker Compose up API, and I have my API running. That's all I had to do, and now I'm running on localhost here. This works just as well if you've got some dev server or production, whatever. And I didn't mention this before. If your organization doesn't have containers on their roadmaps at all, don't discount this. I've never used containers in production, but they've been immensely useful for development. So even if that's not a thing, your company's never going to use containers, they're so useful just for local development and for testing and all of that. You had a question?
Yeah, one thing I would add that what I've used before is that it's almost like you're reading out the sandbox.
Yeah.
File system, users, everything you can think of is segregated out. And even if you've got a license search to start over here, come over to this container, you'll have no concept
Yep.
of the license search, the files, the memory, it's all
Mm-hmm.
separated out. So you can literally take out the container, blow it away, keep the other.
Yep, that's absolutely right. That's a good point. Yeah, so the point he was making is a really good point about containers, is they're fully isolated. So even though I have these 4 containers running on my local machine right now, they have no concept of each other. They're their own unique file systems. They have their own, I can set up security inside of each one of them differently. I can expose different ports inside of each one of them differently. Inside of the container, whatever's running in there, it just thinks it's running on its own hardware. It doesn't know anything different than I am an application and I'm running on top of Windows. It has no concept of the outside world. Yeah.
So the question was about if you aren't going to deploy a container for production,
Mm-hmm.
it's still useful in dev. So then how do you differentiate it? Is it basically you're just going to rely on that .NET Core publish thing? So then you just run that command on a target server rather than on a target container? Basically
Yeah.
development and how do you have that integrity of deployments being consistent?
That's a good question. So the question was how do you have integrity of deployment between I'm running this in Docker locally, but I know it's not going to go into production inside of Docker. And that's actually the reason that I got into Docker in the first place, or how I discovered Docker, was that where this thing lives, the client that we're building this complicated application for, they've got a really complicated development environment. Like the alternative would have been devoting a space inside of our office to bring in specific hardware, specific services, specific servers that have to have specific hardware. Inside of those, they would have to have specific host names and certain environment. Like it would be a lot of work to actually set up a true production environment for this. And so we do everything inside of Docker. And so since inside of Docker, I can have control over any environment variables, any network settings, any group policies, anything that might make that environment unique. I have full control over that inside of my container. I can simulate a production environment. So even though it's not going to be the same hardware, it's the same environment as far as the application's concerned. And so it actually gives me more confidence of doing this inside of Docker, because I can have a more production-like environment inside of my containers than I would trying to implement a bunch of workarounds, because I can't actually reproduce a full production environment outside of production.
So like on the deployment part, do you have, actually, if you have multiple deployments,
Mm-hmm.
if you have multiple managed environments, I guess you wouldn't have a deployment for your test
So the question was if deployment is different between containers and production, how do I know that, how can I trust that deployment in production is going to go as well as it does in containers? And the way that we handle that is our deployment process to a container is the same as production. So if there's an installer that I would normally run going to production, I just run that installer inside of the container. If there's certain deployment scripts, if I've got some type of, if I've got a SQL script that needs to be run, or I've got whatever my deployment process is, I duplicate that inside of a container. And that's part of, I think, what makes it hard to get our hands around a little bit with containers, is containers seem kind of abstract. We can really treat them just like a machine. So the same script I would run on my real production machine, I can run that inside of a container. And I can have effectively the same deployment process inside of a container as if I was actually deploying on the real hardware or the real virtual servers that are production. You had a question?
Yeah, and it's kind of an extension of the question, which is to, okay, in my development environment, my development version of the app is pointing to, let's call it dev SQL 1.
Mm-hmm.
And that's a separate machine.
Yep.
Now, if I deploy that container into production, it's still going to be looking for dev SQL 1.
Yep.
There's a DNS issue there that needs to get resolved, and I'm not sure where that resolution is.
Sure. So there's a couple ways you could handle it. What I like to do is I just run SQL inside a container. So if I'm running this in my local environment, I have a container that's running SQL. And it's actually really cool even for local development. If you're working on something that this needs SQL Server 2008, this one needs 2014, I don't need both installed on my local machine, or I don't need two boxes I can go hit. I'll just have a SQL 2008 container and a SQL 2014 container. I can run SQL inside of containers just like I can run anything else inside of containers, which makes it really cool, like you mentioned, with being able to blow away environments. I don't have to have some kind of script to go and reseed my database. I've got my image that has my seed data in it already. I throw away that old database, I bring a new one up, and I've got a new database that I can test against. Yeah, Lucas.
So are there other container management technologies out there that compete with Docker? And then what are some of the differentiators that Docker has, maybe its features, maybe its pricing, that led you to choose this tool?
So there are, and I'm not going to be able to speak real well to them. The one that the Docker is kind of standing on, or originally stood on, was LHC, Linux containers. That's been around for about 10 years or so. I haven't personally tried it, but my understanding is it's pretty unwieldy. That's kind of why Docker came out head and shoulders above, was Docker just made it easy. When you start getting into clusters, you've got Docker Swarm versus Kubernetes. Again, I haven't played with those much. I will say about Docker is that it's the most user-friendly. So unless you just want to play with something else, or you have some really unique requirement that Docker doesn't fulfill, I have not seen a reason to move away from Docker. It's done everything that I've needed it to do, and it's been really easy, relatively speaking. That's what I'm using, actually, is the free version. So the thing that's great about this, and even the Microsoft images, which we all know how Microsoft does with their licensing, you can use all those for free. As long as it's not production, it's the same way with MSDN. You can download any of their stuff and use it as long as it's not production. Docker's the same way. You can use any of their base images. So if you need to test something against a different version of Windows or a different version of Windows Server, you can just pull that image down and go from that. Yeah.
Something you just said set off the alarm bells. When I was first looking at Docker a while back, one of the key features of it, especially with Docker for Windows, running Windows containers, those additional Windows containers didn't require additional licensing. Is that either a misunderstanding on my part, or has that changed?
So I don't have experience with production, and anytime the question, I'm getting a sign in the back to repeat the question. So the question was just about licensing, and if it really is true that production containers or production images would require licenses. I'll say this because I'm about as far as you can get from a Microsoft licensing expert. I may have misspoke. It may be the case that if the host is licensed, that the containers don't matter, that you can run any number of Windows containers, Microsoft containers on a licensed host. Okay. And you may be right. My mind is definitely not, like you mentioned, there's a world of difference between running for development and testing as opposed to running in production. And that's, when you start thinking about licensing and you start thinking about container health, that's really more of where Docker falls into the DevOps side. I mean, there's a whole other talk, a whole other series of talks you could do when you're talking about Docker for DevOps as opposed to Docker for developers. That's a really good question about licensing, and I couldn't tell you for sure answer, but I think you might be right on that. If I had to bet, I would take that bet that you're right about the licensing. So, yeah, one more question.
Does Docker have like a tool that will help you capture those weird environments, like if you're finding out or creating a container or something like that?
Not that Docker itself, I'm fairly certain doesn't have any tool like that. There might be some third-party thing that can help pull environment settings out.
So how did you replicate your environment?
So we dealt with a lot of pain trying to replicate our client environment before Docker. And so we had a lot of workarounds in place to do that. We were actually using Vagrant before, and we were doing this inside of virtual machines. And it kind of worked, but it was a long ways from the real production environment. And so this wasn't a build from scratch thing for us when we did this. We already had a lot of that figured out through a lot of trial and error doing this in Vagrant. If you have a complicated environment, there's probably going to be a lot of that, a lot of figuring out, oh, well, that works because of this really unusual setting on the box somewhere. IIS has some weird configuration, or there's an environment variable, or there's some type of permission issue, or whatever. The more complicated your project, like I said, there's a lot of hand-waving here to do this in 45 minutes. So the more complicated the project, the more work you may have in actually getting a correct environment set up inside of Docker. But the tools are all the same. It's just going to be, you're going to have more steps in your Docker file to configure those various environment settings to get it that way. Did I give you a hacky sack? I have a bottomless bag of hacky sacks down here. It's Mary Poppins' bag.
No, it's not. I think of a question.
Let me wrap through this real quick because we're running close on time, and then I'd love to take any more questions, and I'll hang around for a little bit for anybody that wants to talk. So let's actually look at this. So we've kind of talked about everything as far as just bringing up an application. I've got an API, and we're pretending it's a complicated application that has a whole bunch of dependencies that wouldn't be practical to run locally. In that case, those dependencies for us are going to be Elasticsearch, Logstash, and Kibana. It's our logging solution for our fake application here. So all that's running inside of Docker, all of that works, and if we come out here, we can see we have Kibana running. And I've got this way blown up so I can, there we go. So you can actually see our request that came through about 10 minutes ago. We can see our client ID of 6, which is the parameter that we passed. So we hit our API, that went through Logstash that's running in a container, that talked to Elasticsearch that's running in a container, and then Kibana that's running in its own container talked to the Elasticsearch container and gave us this nice, pretty graph. So all this is happening inside of containers, and it's all on my local machine. So let's talk about a client application. So I've got a client out here. And all my client is going to do is going to hit an API, and then it's going to pass its own host name as the parameter so that we can see that client is hitting our API. So this is going to come up inside of its own container, and it's going to call our API. And one thing you'll notice here is that it specified all the dependencies, so it had to make sure all of its dependencies came up. Oh, and I ran that detached. I shouldn't have done that. So the flag that I mentioned earlier, you can run it attached or detached. Detached just says, I don't want to stay in this container. I don't want to see all the output from it. Just start it, and I'm going to forget about it. So if we bring our client up again, we'll actually see all the calls that it's making. So we can see that it actually called Docker API. It knew what that was because the DNS resolution happens inside of the containers, and it called this API endpoint and passed its value. So if we come back out here to Kibana, we can see all of those that just came through. So our client ID was passed through, and we can see all of our requests. And you can actually go filter that and see a little better. So we can see here's our 20 requests that came through from our client application that we just hit. So what's really cool with that is, what if I want to have multiple clients hit it? What if I want to do some load testing? What if I need to simulate more activity on this? Well, I can do Docker compose up, and I can pass a scale command. And I want to have 5 clients. We're going to run those detached because that's going to be a lot of output. Oh, maybe not detached. Okay, we'll run them attached. Live demos are great. So we're going to see a bunch of output here. So what we're actually seeing right now is it attached to every container that's running. So this is actually what's going on inside of all of our containers right now. We've got 5 clients that are each making 20 requests every second, and then they're going out and hitting our API. Our API has output. It's sending that to Logstash. It has output. It's sending that to Elasticsearch. It has output, and it's sending that. Or then Kibana is then updating and reading that, and it has output. So this is everything that's happening behind the scenes in our containers right now. And if we come back over, we'll now see all of our client requests coming in. So we can see that inside of Kibana, that we now have a total of 120. Our 20 that we originally ran, and then we have our 5 that each made 20 requests. So we've got a whole total of 120. So all of that inside of my Parallels, it's running on my MacBook, so I'm already virtualized in Parallels, and then I've got all of these containers running on top of that. So I just had, what did we count? 5 plus 4 more, so 9 virtual machines running inside of a virtualized environment on my MacBook. So like, you'd never be able to do that with a real VM. So Docker lets you do some really cool stuff without using a ton of resources to do it. I've got all this on GitHub, so if you want to go out there and play with it for yourself, please be my guest. I've got some basic instructions out there, but feel free to, shoot me a question if you have it. So you can go out there and play with it. Because it's Docker, you should be able to just pull all of this down on your machine, and it should run exactly the same way without any special configuration. Yeah?
Actually, a real quick question. So when you build an image for your development team and you get a new guy who has a fresh clean box, what does he have to do? Just install Docker and run an image? Or run a
Yeah, so the question was, if you've got this complicated environment set up, what's a new guy coming in have to do to actually get this running on their machine? And there's a couple of ways you could do it. The simplest way is just let them build the images, because they should build the same on any machine regardless. The same way that I ran Docker Compose up, I can run Docker Compose build, and it will build all of those images that I've specified. So with one command, I can build as many images as I have defined in that Docker Compose file. The other way you could do it, if you really had a bunch and you didn't want to have to rebuild those, is you could use some type of image repository. You could host something locally, you could put it on some cloud provider, and you could have pre-built images that are out there that somebody could come in and download those if there wasn't reason for them to build those locally. All right, now the official question time, which is a couple of minutes we have left before we have time. Yeah. Mm-hmm. Yep. Sure.
If a client is looking for saying API call and it can be served from any one of these containers,
Mm-hmm.
my understanding is fine. So when database gets updated, how does it get synchronized from one of the containers? Because some other content goes to a different container, and I want to update it in the database.
Sure. So the question is how do you synchronize amongst multiple containers? And I don't know if I'm understanding the question exactly, but I'm going to say that you're talking about like a clustered SQL instance.
Synchronizing the database inside the container.
Okay, so yeah, so you just have multiple containers that need some type of synchronization. So there's a couple of ways you can do it. That's really getting to something like Kubernetes, or you're talking about like a cluster of containers, and it handles. I haven't played with Kubernetes much, so I'm not going to be able to speak a whole lot on that, but there are technologies out there to manage a cluster of containers. The other thing that we didn't talk about is while these containers are self-contained and I can bring them up and I can throw them away, I can also give them a volume. I can give them a persistent storage. So if I do have something like a database and I don't want that database to go away every time I bring down my container, I can give that a place to store that on my host. And so it'll bring up the container, it'll then read from that persisted storage. Everything else will be transient. It can come up and go away, and it doesn't matter. But I can actually store files physically on disk, and they'll stay there. Yeah. Nope. So that's actually a really funny question. So I started this on Windows containers, and actually I'll preface this by saying all the stuff that I'm really doing for real development are all on Windows containers. The reason that I switched to Linux containers for this is, funny enough, Visual Studio, the Docker file that it builds, wouldn't run in a Windows container. I don't know why, but I switched to Linux containers and it worked. But that's a funny thing we didn't talk about, and we don't really have time to get into too much, is that you have Windows containers and you have Linux containers. And if you're running Linux containers, it doesn't matter what your host is. It doesn't matter if it's Windows or some Linux variant. It'll all run the same regardless of the host. So there's some cool stuff you can do, especially to save on, like if you're doing a cloud infrastructure, you can save a lot of money using a bunch of Linux hosts and running Linux containers because all the Windows images will run on top of Linux. And you can't tell it other than you may see some Linux type output.
So, not a big difference for Windows. I haven't read much into it yet, but Windows Server 2019 is coming out with more containerization support, maybe more native. It's even going to be better.
I've used Server 2016 and their native container support. It's okay. The networking is a struggle. I've had to reinstall Windows a couple of times, messing with the built-in Server 2016 containers. So I've played a little bit with 2019, but not enough to know. I'm hoping it's better. But even if not, like I said, Docker runs great. The actual Docker runs great on Windows without the native containers.
And on the .NET Core side, I mean, we basically have said until we migrate things to .NET Core, we probably can't containerize them.
Mm-hmm.
We have a lot of legacy on .NET framework.
Sure.
So, but I didn't know if we had any experience with
I do. The question is, does this have to be .NET Core? The only thing that .NET Core gives you is it makes it easier to do this as far as building goes. The big application I keep alluding to is not .NET Core. There's a build script that runs that builds everything and gets all the output, all the artifacts, into a Docker folder, and then all of our Docker files point to that Docker folder to copy all of the artifacts over. So if you've got your build process scripted and automated, then as long as you can point your Docker file to that output, you can use Docker for everything else. That's a great point. Yeah, you have to use Docker for Windows. Mm-hmm. Yeah. Mm-hmm. Yeah, so the Docker Community Edition I'm running is Docker. Yeah. Yeah, if you're running Windows 10 Pro, the normal Docker, the Community Edition, is what I'm running on here. It works great. If you're going to use the built-in, it's Docker on Windows. You have Docker for Windows and Docker on Windows. Docker on Windows, which uses the built-in Windows containers. I've done it on Server 2016. Works okay. Networking's so I think we're about out of time. So if you have any other questions, I'll hang around for a bit. I'd love to answer any other questions people might have. Did I miss? There's so many questions. Did anybody not get a hacky sack that asked a question? That's important. Yeah, I got him. Okay, cool. Awesome. Well, like I said, I'd love to connect with you. Hit me up on Twitter. You know, I've got this out on GitHub for you to check out, and that's it. So thanks everybody.